Okay, to wrap up section 1.4, I'm going to try a problem here that will allow us to apply some of the things we just learned regarding the different trig identities and whether trig functions are positive or negative in each quadrant. Okay, so the problem I have here, find the other 5 trig functions if the tangent is root 7 over 3 and theta is in quadrant 3. So I'm given 2 pieces of information, the value of the tangent and the quadrant of the angle, and I'm asked to find the 5 other trig functions, the sine, cosine, secant, cosecant, cotangent. Okay. So I'm a visual person. I like to draw diagrams, and I'm going to first draw a diagram with an angle in quadrant 3. Okay. So I'm going to make this sort of big, but I'm going to emphasize the third quadrant here. I'm going to put an angle down there. Doesn't have to be perfect angle. It doesn't have to be exactly with where this would be, because I don't know exactly where it's going to be. I just need an angle down there. It's going to be good enough. And I'm going to create a right triangle going back up to the x-axis. Now, generally, we think of the angle theta as the angle at the origin in the triangle, but in reality, angle theta really comes off the x-axis and wraps all the way around. But all the side measurements that we're going to deal with are going to be with this triangle in the third quadrant. Okay, so I know that the tangent is root 7 over 3. I also know the definition of the tangent. Remember SOHCAHTOA. I'm going to refer to this a lot, but I'm not always going to write it out. So you're going to need to remember what that is when I say it. Tangent is opposite over adjacent, right? So the tangent of theta is the opposite side over the adjacent side, which is y over x. Okay, so tangent theta is y over x. That's a fraction. Here I have a fraction. If I had a decimal, I would just convert it to a fraction so that it matched up. Y over x, well, that means the y must match up with the root 7 and x with the 3. Okay, so my y side here is going to have a length of square root of 7, and the x length is going to be 3. Well, in the third quadrant, we know that both x and y are negative because you're going left and down. Okay, so these coordinates are actually negative values. But again, remember, if you divide a negative over a negative, you'll get a positive value for your tangent when you divide them. Okay, double negative there. Now, the first of the 5 trig functions, the easiest one is the reciprocal of the tangent, right? So I know the cotangent right away, because the cotangent is always just the reciprocal. So the cotangent is 3 over root 7. Okay, that one's not too hard. However, we don't want to leave a root on the bottom. Remember, we had a review video from section 1.3 where we talked about rationalizing denominators. This is where it's going to get into, or become important. Okay, and you're going to find this in my math lab a lot. They don't want roots on the bottom typically. So I need to rationalize that denominator. We're going to multiply this fraction by root 7 over root 7. Remember, that's how we rationalize those, multiply by the denominator. On top, we're going to get 3 times the square root of 7. And on the bottom, the root cancels and you just get 7. Nothing reduces further because nothing on the outside of the root has a common factor. So the cotangent then is 3 times the square root of 7 all over 7. Okay. Now the other 4 trig functions, again, once we find the sine, we'll be able to find the cosecant by doing the reciprocal, and same with the cosine and secant. But for right now, we got to focus on those. So let's do the sine and the cosine, and then we just flip them to get the other ones. Okay, so we'll start with the sine. Also remember that our quadrants, we had that AS TC abbreviation for all the trig functions are positive in the first quadrant, sine, tangent, and cotangent, or cosine, respectively, in the others. So here the tangent's positive, but that also means all the other trig functions are negative, including the sine. So I know that the sine is going to be a negative number. The sine, however, is opposite over hypotenuse, which is the root 7 over the hypotenuse, but I don't know the hypotenuse yet, so I've got to find that. To find an unknown side of a right triangle, we use Pythagorean theorem. Okay, so I'm going to take that over to the side here. Pythagorean theorem, well, I'm going to call that R. So I know that R is equal to the square root. Now I'm taking the square root in the Pythagorean theorem. The square root of the x squared plus the y squared. So negative 3 squared plus negative root 7 squared. Of course, the negatives aren't really necessary because when I square them, they become positive. So we get the square root of, well, 3 squared is 9. Square root of 7 squared is just 7. And that works out kind of nicely because 9 plus 7 is 16. And the square root of 16 is 4. Okay, so I have a nice whole number for the radius r. So r is equal to 4. That works out well. Alright, so now my sine is going to be opposite over hypotenuse, so it's negative root 7 over 4. That one's not too bad. Okay. The cosecant is the reciprocal of this. So I just flip that. It's negative 4 over root 7. Unfortunately, the root's on the bottom now, so I have to rationalize the denominator. Okay, you're going to get very familiar with this, maybe a little annoyed by it, but it's going to need to be done. So we multiply by root 7 over root 7. As you do this more and more, the final answer may become a little bit more apparent. This is going to be negative 4 root 7 over 7. Okay, so that's the next one. We only have 2 left, and again, once we find the cosine, we can get the secant from that. So the cosine of theta is, remember, cosine is adjacent over hypotenuse, so it'd be negative 3 over 4. Okay, and that means that the secant, which is its reciprocal, is negative 4/3. Okay, that should give us the remaining 2 trig functions. Now notice we were not being asked to find theta. We don't actually need to know what that angle is. It can be found, and we will find that later in the course. We'll be dealing with what the angles are. But right now, we're just trying to work with the ratios of the sides of the triangle. So always remember that trig functions represent ratios of sides, okay? The sides are in the definition, right? So the SOHCAHTOA idea. So here the tangent is opposite over adjacent. If you see a fraction or a decimal, like I said, you can convert to a fraction. Then the numerator and denominator are the corresponding sides of the triangle.